everybody, and welcome back to another episode of Career Chats. I'm Natasha, part of Space Club's Mission Control, and we are so excited to welcome all of you Space Club students, as well as teams that are in the New Worlds Await You Habitat Design and Technology Competition. Good luck to all those teams. So today we have another guest from Southwest Research Institute in San Antonio, Texas. And I'm really excited to talk with her and ask all of your questions about her background, her experience, and her work in STEM. And of course, we're going to have a raffle and we're going to do a highlights video, so make sure to stick around. Okay, so to get started, today's guest is Rebecca Perryman, who is a lead engineer at the Space Science and Engineering Division at Southwest Research Institute. Her educational background is a bachelor's in mathematics and sociology from Trinity University, an interesting combination, and a master's in industrial engineering from Texas A&M University. Let me bring Rebecca on. Welcome. How are you doing?
Doing good. Thank you for having me today.
All right. So before we jump into the questions, I noticed this double bachelor's degree. Can you tell me about getting a mathematics and a sociology degree?
Sure. Yeah. When I went off to college, I knew I was going to study math because I'd always loved it. And so I went and I started taking math classes. And then I also started taking a few sociology classes. And I was really interested in how different groups in our society interacted and how just as a whole society we formed over the years and how we interact with people. And so I kept taking more and more sociology classes along with my math classes and ended up with a degree in both fields.
And I think that's cool because a lot of times students think they have to pick, like I have to stick with math or have to stick with science. So it's interesting that you have, what we consider like different sides of the brain, right?
Yeah.
So let's jump into the questions because I'm imagining this is kind of a theme perhaps throughout your story. So why did you want to be an engineer? This is from The Aliens in California.
Well, I didn't always want to be an engineer. The one thing I knew ever since I was little, and you can see me when I was in elementary school here, was that I just really loved math. I liked doing math problems every chance I get, and I would just solve problems anytime I could. And that continued on through the years. And the more I practiced and I got to learn new things and solve different problems. And so, like I said before, I went to college and studied math, and I'd planned on becoming a math teacher. That was the main career that I'd seen women in math going into. And so that was my plan. And my very last semester of college, I had a professor pull me aside and say, hey, have you considered going into industrial engineering, which is kind of the direct application of math to real world problems? And I went to a conference and watched some presentations, got to see a little bit more of what it was, and ended up going to grad school the next year in that field to kind of see what it was like and if I wanted to continue down that path or not.
And the second question here from the Martians, who encouraged you to be an engineer? So was that professor like the key figure that changed your trajectory, or are there other people?
Yeah, I think I'll say ever since I was younger, my mom really encouraged the math side of life. She got a college degree in math right after I did. And so I'd had that, but I didn't really have a lot of influences as to what career to go into. And so it was that college professor who had a really big impact in showing me what some other opportunities were and encouraging me to try them out. One of the things I remember at that time when I was thinking about switching was that I didn't know if I wanted to do that or not, but it was an opportunity that I could either take or not take. And I decided to go ahead and take it. And if I went down that path for a while and didn't like it, I could always reevaluate and switch over back to kind of the professional path of being a teacher too, or maybe they would come back together and merge one day. Just taking opportunities as they come.
And as a kid, you just don't know what you don't know. Like it's hard for kids to say, I'm going to be an engineer or an astrobiologist if they don't know what that is. And that's why I love these career chats, because they get to meet people like you, and kind of maybe that's something they can do someday.
Yeah, I think when I was in elementary school, my family had a produce company, and so we sold produce at flea markets or on the kind of the side of the road. We would have a fruit stand, and I really understood that kind of business, but I didn't know anyone who was an engineer that I considered to be a role model. And so it wasn't until I started getting to kind of meet other people and see things. And yeah, I'm really happy to be a part of this for that same reason.
All right, well, let's talk more about what you do. So we mentioned that you're a lead engineer, and inevitable stargazers in New Jersey want to know, what is difficult about being a lead engineer?
Well, I think one of my main roles in the work I do is to work with lots of different teams of people and understand what they're doing. And that can be difficult because a lot of times, depending on what field you're in, you're used to speaking a certain language. So computer scientists are really good at understanding code and software and all of that type of those types of things. And like mechanical engineers are really good at understanding how to put things together and build really complex things. But on flight instruments, we really need those people to start talking so that we can understand how to put together a really good instrument that we're going to send out into space and then can't necessarily go fix the hardware on it. And so that's probably the most difficult part of my job, is learning to talk to people in a lot of different fields so that I can make sure that our both our instrument we send out is going to do what we need it to do, as well as that I know how to operate it and how to solve problems with it when they arise in flight.
Yeah, and I think that's important for kids to know. Communication is a huge part of this world of STEM. It's not all just numbers and, equations. So let's give them a sense of, like, what is it you do? So one of the projects you told the students about was the Cassini mission. So can you tell them a little bit about that?
Yeah, so I am an operations engineer on a mission, and so what I do is I talk to scientists. So we'll have some instrument out in space that has a certain science goal for that mission, and the scientists here on Earth, and most of the scientists are all over the world, not just at Southwest Research Institute, but they'll have a certain goal, some experiment they want to use that instrument for, some data that they want to get down from a certain planet so that they can better understand it. And so I talk to the scientists, translate that into commands that tell our instrument what to do, maybe what masses to measure so that we can know if there's hydrogen, nitrogen, oxygen, things like that in a certain atmosphere. And then I put together a commanding file that we basically send out to the spacecraft wherever it is in the solar system, and it gives the instructions for the instrument to know how to collect that data. And then the other part of my job is being the one to receive the data when it comes back from the instrument and comes back to Earth. And I'll look at it to make sure that the instrument's working as we expected, that it's still healthy, and that there's no safety concerns. And then also to provide that data to the scientists and work with them if they have any questions about how the instrument worked, that they would need that information to learn and infer new information about different bodies in our solar system. So
that's really cool. So you could just say, I just talk to stuff out in space all day.
Yeah, basically.
What is I don't know how to question, like, what's an unusual command or something that's like weird that's happened in talking with these spacecraft?
Well, most of our commands are just things that we need it to do. So if I were to look at my daily routine, I could say, okay, I know that every day I'm going to wake up. So I need to set my alarm so that I'll wake up in the morning. And then I know I need to brush my teeth. Then I need to kind of go through my whole day. And so what we do when we're designing an instrument that's going to go out into space is we ask those same questions. What do we need this instrument to do? and what are the detailed steps it's going to have to take to do that. So for brushing my teeth, the types of commands you might generate are, okay, walk to the cabinet, get your toothpaste out, get your toothbrush, put the toothpaste on the toothbrush. So really breaking it down into those pieces. So we try not to do really crazy stuff out in space when we're far from the Earth, because we want to be very safe and not break our instruments. But sometimes we get surprises. So up on the screen, you can see Enceladus there. And the Cassini mission was a mission that went to Saturn and orbited Saturn. And Enceladus is Saturn's fourth largest moon. And what they did not know when Cassini first launched was that Enceladus actually had kind of jets going out from its south pole, and there was water ice going out the bottom of it. And so some of the commands that we would send when we're orbiting a planet like Saturn is to collect information about certain species or compounds that could be in the atmosphere. And so once they started seeing that there was something different about Enceladus, we would change up our plans so that we were investigating what was coming out of the South Pole. And that's when they were able to use the instrument I worked with to determine it was water particles and ice coming out of the South Pole. So we kind of have this basic set of commands that we're able to do a lot of different things with. And we're always kind of adapting when we learn new information as to what the next commands we might need to send are.
Yeah, that's so cool, because it's like you send it out there with like certain scientific missions, but you don't always know how it's going to play out because you're exploring and you don't know everything.
Exactly. Yeah.
Really cool.
So when we send commands out to somewhere like a spacecraft orbiting Saturn or Jupiter, we will send them out for a longer period of time. So we might sit down and say, okay, for these next 4 weeks, here's what we want to do. We know we have 2 flybys of Saturn's moons. And so at these times, we want the instrument to do X, Y, and Z. And so we kind of plan things out in advance when things are so far from the Earth, and we send them all at once. And then those robotic spacecraft just kind of tick down the list when it's time to do each thing.
That's cool. Okay. Well, let's keep going with sending those commands. So the Galaxy Nerds in Indiana ask, is it hard to send those commands to spacecraft? So what challenges do you face in sending those commands?
I think that the process of generating those commands can be kind of hard, and we've touched on some of this already. So one of the difficult things is that on these science missions, we don't know exactly what we're going to get back. So we're kind of adapting all of the time and trying to think through what the best experiment would be to get the most information. And then the other challenge that comes up is what I mentioned before of needing to talk to the scientists on Earth to figure out what they want to do with the instrument. So this is where that communication really comes into play, where a scientist who has lots of knowledge about certain physical systems or properties will say, I'd really love information on a certain physical process on Enceladus. And then I have to work to kind of translate that into what the instrument can actually do, because it can't do everything that instruments on Earth can do. And then also translate that into those detailed commands. So being able to break stuff down into just little bite-sized pieces, kind of like how I was talking about with brushing my teeth, being able to break it down and know that I need to walk to the cabinet and what I need to get out, and listing those out one by one.
How long does it take for a command to reach a spacecraft?
So it depends on how far the spacecraft is. When Cassini was out at Saturn, which I should mention that I spent a lot of my career so far on the Cassini spacecraft, but it actually plunged into Saturn in 2017 and no longer exists. But when we were sending commands out to Cassini, it took between like an hour and 12 minutes to an hour and a half for those commands to get out there. So if we were wanting to send a command and then get the information sent right back to us, you're looking at 2.5 to 3 hours before you would actually see what the result of those commands were. But most of the time we didn't get information back that quickly. We would get information back maybe once a day or once every couple days. They would send a big dump of information back from the Cassini spacecraft back to Earth using what's called the Deep Space Network, which are really large satellite dishes that are placed around the Earth to receive signals from really far away.
That's cool. Okay, I'm going to switch here to this next slide and talk more about current work. So what are you currently working on?
Great. So right now I am working on 3 different space instruments. All of them are in development. That means we're working on building them and testing them right now. And then we'll hand them over to get put onto a spacecraft that'll launch and go out to space in the future. The first one I'm working on is called MASSPEX, which is the mass spectrometer for planetary exploration. And that's going to be on the Europa Clipper mission, which will go to Jupiter's moon, Europa. And Jupiter's moon, Europa they believe it has a subsurface ocean with a lot of water on that body. And so what we're really interested in is what these different moons are like throughout our solar system that have water. What's going on below the surface? What can we infer from taking measurements of the atmosphere? Because on that instrument, it's a mass spectrometer, and we basically fly through an atmosphere and take samples as we go. And from those samples, they pass back and forth through the instrument, and eventually, when they hit the detectors, we record different information that tells us on the ground when we get back. We can say if there's water there, if there's oxygen, nitrogen, a lot of details about the atmosphere. And so that one in particular is going to give us kind of that information about Europa's atmosphere. And what does that information tell us about what's going on the surface of the planet, what's going on within the planet underneath the surface? And so we're real excited about that mission in particular.
When does that one launch? Do you know?
That one launches in October of 2024.
Okay.
We still have a few years. The first instrument, which is also from Southwest Research Institute, is called UVS. It's an ultraviolet spectrometer, and they just delivered to the Jet Propulsion Labs in California their instrument in the last couple weeks. And it was the very first instrument to kind of finish its building and its instrument testing and get handed over so that it can start getting integrated with the spacecraft. So all of our instrument MASSPEX and the other instruments that are going to go on that spacecraft are all kind of working towards that same goal of finishing up and getting to hand off to the spacecraft so that they can put them all together, test them all together, and then launch in 2024.
That's cool. Yeah. And another project, I think, is the Saturn probe that Apollo 18 is asking about.
Oh, the Saturn probe. So that was part of that Cassini mission that has passed. And I was asking someone today when Cassini started getting built. And Cassini, they selected the instruments for Cassini in 1991, and then it launched in 1997. So that was six years that they were developing the instruments and putting them all together. And that's fairly similar to a lot of these deep space missions like Europa Clipper also. We've spent a lot of years designing the instruments. So even before we know what mission they're going to go on, folks at Southwest Research Institute have spent the last 15 years coming up with the ideas for these instruments that we have now and making prototype instruments and testing them out and really evolving them and improving them over time. That's way before I was at Southwest Research Institute, but they just continue to work little by little. And now it's an instrument that's going to get to go out into space, which is neat.
What's your favorite part of your job in developing all these instruments?
I really like problems and doing things. And so my favorite part, I think, is that you get to go in, you get to work on something for a while, and then eventually you get to see it actually out in space and sending back data that other people use to make sense of our solar system. And I just think that part is really neat. I'm not a scientist where my sole love is in that final learning part. I really like the action of doing something from the very beginning of just solving little problems. But then it's neat to see that whole process kind of end with scientists making really great discoveries. So it's neat to do stuff and neat to see other people do great things with it.
And we've talked to a few scientists that are just very passionate about that final piece of the discovery and what's out there. And I love your perspective of you get to be part of the design of the tools that allow them to make those discoveries. And all these pieces are so important. And that's for students to kind of figure out what they're passionate about. Just because you love space, like, it doesn't put you in a certain box. Like, there's just so many different places for kids to be involved.
Yeah, until I started working in space, I hadn't even thought through all the different roles, even down to the level of that there are, graphic designers that we really rely on to be able to take our ideas and show them visually. So they're not scientists, they're not necessarily mathematicians. Some are artists or computer folks that understand computers way better than I do. But really, when we all come together, we're able to kind of put all the pieces together and make sure they all make sense, and then use all those tools to communicate to others.
Yeah, I love that. Okay, so we're going to switch now to life outside of work. You got a lot of questions about your kids. So let's ask, what are your kids' names?
Well, I have a lot of kids. I have 4 kids. And their names are Zayden, Zarin, Ricky, and Riley. And they're we have kindergarten through a high schooler. So we kind of have the whole nice age range going on right now for school-aged kids.
And are your kids interested in NASA and space?
Each of my kids has a different interest. I think they all love hearing about what I do, and they like knowing where these instruments are going to go. And especially there are certain periods of time where I'm working more in a week than I normally would. So there's times when we kind of talk with the kids and say, okay, this week I'm going to have to go in an extra night to go do some testing in the lab. And so they like knowing, okay, you're spending some time on that. Where's it going to go? What's it going to do? And they get excited about that. But my oldest, he really loves reading, and his imagination is really great, and just reading lots of books and seeing how that comes together, and loves animals. And so what I find really neat is to see where our conversations are going to go. If you love math and you want to talk about math, then how do these things connect? How does math connect to space? But also, we have to remember that Earth is a planet in our solar system too. And so getting to hear kind of his ideas on animals and climate and things like that, and helping me understand more about our own planet, is also really cool when you're kind of just having space discussions in general.
Yeah, that's cool. Well, that's kind of answering the next one, but Explode Pluto wants to know, what do you like to do with your kids?
We like to play a lot of games, a lot of board games, and they like to play some video games sometimes and watch movies. So I get to learn new things all of the time in that realm. And then we also like to go out for walks and go hiking and travel different places and visit family. So yeah, just spend some time together and enjoy talking with each other and other people around us.
And this last question I think is great. So what is it like being a mom and then just having this job that you do, and you're getting to do really cool stuff at work, but I'm sure it's a lot of hours. You mentioned, sometimes you have to work late. So what is it like?
Yeah, I think it's really rewarding being a mom, and it's really rewarding having the job that I do. And so getting to just share both of those things, getting to share kind of exciting stuff about my family at work and getting to share my work excitement with my family is a really kind of fun and enjoyable part of my life. I will say it's hard finding balance in things. And that goes for almost everyone, whether they have kids or not, trying to find where that work-life balance is. So I mentioned working late. I try not to do that on a regular basis because I want to make sure I'm balancing my own health, my time with my kids, and my work. But it's definitely a challenge in that respect to try to figure out exactly what I want in my work life and in my family life and for myself, and make that happen. So I think one of my biggest challenges once I started working and having kids in my life was taking the time to figure out not how I can have my life look like anyone else's, but instead just figuring that out for myself. So my work life and my just overall life in general is very different than my mom's was, or some of my siblings are, and my coworkers. But it's really great to start realizing that I can spend time at work and I can spend time with my family and I can get help for some of the things around the house that maybe I might do if I were home for a lot more of the day. But, I think there's lots of different jobs in our life that are all extremely valuable. And sometimes we have to pick which ones are going to be our focus and which we're going to get some help with.
Yeah. And I think it's great to talk about this with, this is a question for middle school kids, right? So that means they're already like even thinking about it, and that they're like, do I have to pick? Like, I really want to be a mom or a dad someday, but I also have like these big aspirations. And the answer is no, like you can do it all. And you don't have to limit yourself. And so I think that's really great to kind of hear from you. And like, you have so many kids, all these different ages, and you're doing such cool stuff at Southwest Research.
Yeah, I think, when you're saying like you don't have to limit yourself, I think that really is the key to things. Is you have to take the time to just look at what you want your life to look like, and know that just because you don't know anyone who has that life doesn't mean you can't work to have that be your life. You're allowed to choose that for yourself. But it sometimes takes some work and figuring out, and it's messy some days and wonderful other days, and it's kind of just sticking with it and taking it day by day. No matter if you have kids or not, or if you're kind of a working outside the home or working in your home, taking care of your family, either way. I think some of those are the same challenges as you get older.
Yeah. Okay, so we're now going to move to the final round of questions. We call this rapid fire, which means you're going to get about 15 seconds per question. Are you ready?
Yeah, let's do it.
Do you enjoy what you're doing?
Yes, a lot.
Would you rather explore the moon or Mars?
I think the moon. I like that I can look up in the sky without a telescope and see some of the features of it. So I think I'd like to explore the moon, take a walk there.
Ooh, take a walk. Love that. What is your favorite board game?
Ooh, that is a good one. I really like playing Rummy Cube with my kids and my grandparents and my parents. That's one all around that we love. I guess I like numbers, so that makes sense.
Total sense.
Yeah.
Are there any other planets besides those in our solar system?
Yes, there are lots. Other solar systems, other galaxies. That's my 15-second answer.
All right, go look up the answer. There's a lot more to that.
All kinds of different sizes, shapes, atmospheres, environments. So yeah, go look and you'll find unlimited information if you just keep going, because we're always learning new things.
That's right. Okay, so what I would like to do now, if you have a couple minutes, is share some of the work from our Space Club students.
Yeah.
So a lot of this is around the engineering design process and, being an engineer. One of their challenges, if for the students are on a mission to the moon, they have now arrived at the moon and they're trying to design a habitat. And this is what we're calling a welcome tower. And so they had to come up with a unique way to create a sign that rotates with the sun because it's powered by the a solar panel. And so you can see like the little LED light. I just thought that's really cool.
Those are really neat.
So they're just getting a little taste of engineering, of what it's like. And then our next group of students are on a mission to Mars, and they're on mission 5, which is to create a Live from Mars report to send back to Earth. So they address these questions like challenges to living on Mars. Some of them featured a STEM professional in their report. So I am going to play that video, so enjoy the show.
Challenges of living on Mars.
All right, what'd you think?
That was really neat. It looks like the projects are using a lot of creativity and innovation, just kind of how to solve problems. And then I loved the videos. It looks like everyone's having lots of good conversations and thinking through things a lot.
Yeah, and this is their one non-engineering design challenge that you happen to be on this week because they previously did a pneumatic device that they had to like lift up rock samples, and then they're going to be designing this rubber band rover to like transport samples, and then this all is going to culminate into a habitat on Mars. And so there's like some cool stuff. And so I appreciate you kind of bringing in the engineering aspect so they have an idea of like, what does it actually look like in the real world?
I think in the real world, one of the things that I've figured out over time is that it rarely looks like what you think it's going to look like at the very beginning. So you just keep trying something out, seeing what you think of it, coming up with new ideas and iterating on it over and over time. So, yeah.
So you're saying that initial design concept like changes drastically from like the final result?
Yeah, definitely. So because you have an idea, you put it together, you see how it works, and you say, oh, it could be improved if I did this other thing. So let's adapt it. And even the mass specs instrument that I was talking about that's going to go out to Europa Clipper, they've been going through different versions of it over the last 15 to 20 years. And for this specific mission to Europa Clipper, it's had a lot of design changes to just make sure it can solve all the problems that occur in Jupiter's environment. So you start with an idea and then you adapt it as you see how it works and as you see new problems you need to solve with it.
Yeah, I love that. That's great. Okay, so to wrap it up, we have a raffle drawing. So one lucky team is going to get this awesome microscope, and you can see it actually includes slides with all these different samples. So like bacteria, I think one of them is cells from a dog's stomach. Like it has really random stuff, which is kind of fun and gross. So every member of the team will get their own microscope. So we are going to do a quick little drawing here. So this is our picker wheel that we do every week. I'm going to
Can I just say, as you're doing that I love everyone's team names.
Right?
It was fun to see them all on the slides and in the videos. So
I agree. They're very creative. Okay, let's see which is. Good luck out there. Beyond Galactives in Redland Christian. Congratulations. All right, so we're going to be sending you a set of microscopes to your school. So as we close here, thank you so much, Rebecca, for joining us on Career Chats. Any kind of final thoughts or words for everybody?
I think just know that wherever you're at, keep learning more and asking questions and taking the time to be curious and hear other people's ideas out too. And life will treat you well. You just keep going one day at a time.
Perseverance.
Yeah.
I love it. Well, thanks for joining us today, and best of luck to all the teams out there, whether you're in that habitat competition or you're on a mission to Mars. We are absolutely loving everything you guys are doing. Have a great week.